everyone. In this session, we are going to explore a very important topic in the IoT domain, that is fog, edge and cloud computing in IoT. As IoT systems grow in scale, the way the data is processed, stored and analyzed becomes extremely critical. Though this presentation, we will understand why IoT needs multiple layers of computing and how edge, fog and cloud together create a powerful architecture for real-world application. So let's recall the last class topic, the core of IoT functional stack. So it contains the analytics layer, service layer, communication layer, and the fourth layer is the device layer. And these are all the today's topics for discussion. That is why IoT needs more than just the cloud, and what is edge computing, and what is fog and cloud computing in IoT, and the edge, fog, cloud continuum, a systematic way of combining, and the real world use case, the remote health monitoring using fog, edge and cloud computing, challenges and solutions in the fog, edge and cloud computing. And first we see about why IoT needs more than just the cloud. IoT devices generate massive amounts of data every second. Sending all this data to the cloud, and then the caches delay, increases bandwidth cost and creates performance issues for applications that requires instant responses like emergency healthcare, smart vehicles or industrial automation. Therefore, processing must happen closer to where data is generated. This is where edge and fog computing must be essential in the IoT solutions. First, we see about what is edge computing. So, the edge computing contains the local processing, ultra low latency and immediate actions. So, the edge computing refers to the processing data at or very near to the source of data generation. So, such sensors, gateways are microcontrollers. These key advantages are local processing and the ultra-low latency value and immediate action for time-sensitive applications. Edge computing enables real-time decision making without delaying and instant cloud servers. And now see about the edge computing architecture. So the edge computing architecture, IoT devices collect data from the initial filtering and perform the initial filtering or decision making at the edge node. Only the required data is then sent forwarded. This reduces network load and ensures the critical actions like alerts or control signals are triggered instantly. And now see about what is a fog computing. The fog computing acts as an intermediate layer between the edge and the cloud. So it extends the cloud's capabilities closer to the network and offers localized processing, the temporary storage and analytics. Fog nodes can handle data from multiple edge devices, coordinate regional decisions and manage communication efficiently. Now see about the fog computing IoT architecture. In fog architecture, data from various sensors is passed through the fog nodes such as routers, switches or dedicated servers. These fog nodes aggregate, filter and analyze the data, allowing scalable and efficient operation. This significantly reduces the delay and makes system more reliable one. Now see about what is cloud computing in IoT. So cloud computing provides a centralized storage. It provides a centralized storage, high computational power and large-scale analytics. It is best suited for long-term data storage and machine learning models and global insights. While cloud alone cannot meet real-time needs, it remains essential for deeper analysis and overall system intelligence. Now, we see about the IoT and cloud integration. So, cloud performs integration with IoT devices using secure communication channels. They offer dashboards, management, big data analytics, and AI-driven insights. The cloud is ideal for tasks that require heavy computation or historical trend analysis. Now we combine the edge, fog, and cloud continuum as synergetic architecture. So the edge layer performs the basic layer of this architecture, and cloud is the topmost layer, and fog layer is the centralized layer in the edge, fog, and cloud continuum. The modern IoT systems don't rely on just one layer. So instead that they utilize a dynamic combination, that is edge, fog, and cloud layer. So the edge layer handles real-time critical decisions with millisecond latency, and the fog takes care of the aggregation, filtering, and regional analytics, and the cloud handles the long-term storage, AI training, and large-scale insights. So this continuum ensures that each computation happens at the most appropriate layer, improving performance and efficiency. So now we see about the one real world case, that is remote health monitoring with IOMT. So that is IOMT is Internet of Medical Things. The data collection at the will be taken care by the edge layer, and the data deduction also handled by the edge layer, and the patient data aggregation handled by the fog layer from the multiple patients at the clinic, and the cloud layer performs the long-term data storage and record maintenance for the particular patients. Now see about the challenges and solutions in the continuum, and we face challenges such as latency, bandwidth limitation, security, and scalability. Latency is reduced by processing in the edge, and bandwidth is optimized at the fog layer through filtering and compression. Scalability performs the elastic cloud resources combined with distributed edge and fog models. The visualizing the impact, the data flow, and architecture. This shows the all the tasks or how the tasks are distributed across the all layers. Only the necessary pre-processed data reaches the cloud finally. So this improves the efficiency, reduces congestion, and ensures the faster service delivery. The future of IoT computing. The future of IoT computing performs the smarter and more distributed systems, that is AI ML at the edge, and energy efficient networks and decentralized security. And this is the summary of this today's topic. And now we see about the test question, that is which statement correctly differentiates edge, fog, and cloud computing in IoT. The answer is B, that is edge processes data near the device, fog acts as an intermediate layer, cloud handles large-scale storage and analytics. And the second question is which of the following computing models is the best suited for real-time IoT applications like autonomous vehicles? The answer is edge computing. These are all the references. Thank you.